All right. This is the Friday morning. So, last day of the break anyway, other than the weekend. So we'll see you all on Monday. These are, as I promised, the ECG notes. We talked about the cardiac conduction system. So how do all the structures of the heart control how the heart functions? So I went ahead and make sure that you read pages 349, 352, talks a little bit about each of this, add your own notes. Remember to these slides as well as you're going through them. And I'll go ahead and post the video and the notes themselves, and you can add to them. Okay, so um, electrical conduction. So in a sense, the heart has its own electrical system, right? Yes, it's controlled by this nervous system, parasympathetics. We don't need to think about it, right? So it does have its own electrical system. So the first electrical impulse is at the SA node or the sinoatrial node, and that's considered the pacemaker. So when you hear that, as far as somebody getting a pacemaker installed, that is actually replacing the SA node. And that starts your atrial contraction. I think we talked about in the blood, that's that lub of the lub dub, right? And then the process goes down to the AV node and then the Purkinje fibers, right? And that's will control the ventricular contractions themselves, the Purkinje fibers. So here's about a short 3.5-minute video that I encourage you to watch that talks about the actual cardiac conduction system. All right. So again, I didn't go into it in depth very much, but you can learn more about it in the reading and then also watching the video. All right, so the measurement of a pulse of the heart or the heartbeats is called a ECG. It's EKG. I don't really know where that came from, whether it's easier to say, but it's technically the ECG. I actually haven't looked up EKG, but it's electrocardiogram, right? So, and that records the electrical changes in the heart. I actually took a class in college where you had a bunch of strips of paper and you got readings and you had to sort of determine what was wrong with the patient based on the electrocardiogram. So anyway, so we're going to talk about how it's divided up. You can see there's a P wave, a QRS complex, and then a T wave. All right, so the P wave is, remember, the depolarization of the ventricular, right? Or the P wave is the atrial depolarization, right? So you can see how it gets more positive. And then the QRS wave, this is the biggest impact on the heart is a ventricular depolarization. So you get the QRS complex or wave is the ventricle depolarizing, and then the T wave is the ventricle repolarizing. All right, so that's needs to you need to understand those, and I think we're going to be doing. I know that actually I don't think we're going to do some activities with this on Monday. All right. So how do we measure the heart rate from readout? There's two methods. So you can do, and we'll talk about each of these, either the 6-second interval, and then you can multiply that by 10, or you can do a 300, 150, 100, 75, 60, 50 method, which is a little bit more accurate. And we'll talk about the difference of these, and you'll still have to do this. So what you do on these is a 6-second interval by 10, you get a 10-second strip, and then or a 6-second strip, right? And then you count how many waves, how many peaks there are, how many complexes found in that 6-second, and you multiply that by 10, right? So here it would be 7 times 10 is 70. So that would be roughly the heart rate. Now it's, this is not as accurate, right? And we talk about this too. It's like when you're taking your pulse, like when you're doing exercise and you're taking your pulse, if you only do it for a shorter period of time, the multiplier is the multiplier of inaccuracy too, right? So however inaccurate you are here on the 6 seconds, you multiply it by 10, that inaccuracy is multiplied by 10, right? So let's say you were a half a beat off, or a half a beat, right? And you multiply that half a beat by 10, well, then that's, um, yeah, that would be what five, five, um, uh, 5 beats per minute that you would be off, right? So instead of 70, it could be 65 or 75. So it's not very accurate. The more accurate is this method where it's the 300, 150, 100, 75, 60, 50. So what you want to do is you want to, it's quick and it's more accurate, right? Because there's no multiplying a in there's no multiplication of accuracy. So the only thing is that you cannot use this with irregular rhythms, obviously, because it wouldn't, you need something that you need a nice regular rhythm in order to maintain its accuracy, obviously, right? So what you do is you find your R wave on the boldest on the line. All right. So and so what you're going to do is, so you can start here, and then every segment is going to, you're going to, like, the first segment is 300. So if the second R wave fell on this line, it would be 300 beats per minute. If it fell on this line, it would be 150 beats a minute. If it fell on this line, like it does here, it'd be 100 beats, 75, 60, and 50, and so on. And the only thing is that you need to, so you can see that it doesn't really quite fall on the 50, but you can estimate it at about 95 or so, right? Maybe a little bit less than 100. All right. So if the second R wave does not fall, it can be approximated. So here we go. Here's our R wave on the line, 300, 150, 175. So it's between 75 and 60, right? So we sort of know it's in between there, and we know sort of that it's closer to the 60 line, maybe. I don't know. So, it may be around the high 60s, right? 68 or so. It's not very accurate. You can see that. I mean, this is it is more accurate, but it's within the 60 and 75, which is a big range. But you could, based on where the line is, you can, say if it's closer to 60 or 75. Arrhythmias, okay, abnormal rate of heartbeat, tachycardia, which is too fast, over 100 beats per minute. And this is at a regular basis. It's not like if you're doing exercise and you get your heart rate up above 100, technically you have tachycardia, but it's not a prolonged condition. These are prolonged conditions. And the other one is bradycardia, where more endurance athletes actually do have bradycardia. When I swam a lot, mine was definitely in the 40s. And that's not necessarily a bad thing if you're in exercise. It just means that you're a lot more efficient at getting oxygen to your muscles. And your muscles are a lot more efficient at utilizing that oxygen. So it's sort of a two-way street. All right, so CPR, we don't really talk a lot about this in this, it's obviously cardiopulmonary resuscitation. Usually when a person has a heart attack, or their heart stops beating for whatever reason, we do chest compressions at a rate of 30 to 2. 30, we give chest compressions and breathing, which is usually associated with it, is giving the person oxygen. And they've actually come up with a method for those who aren't trained if you just do chest compressions and not worry about the breath part of it. If you tilt the head back, usually there's enough air getting into the where the chest compressions make a difference. I was going to add on here the automatic AEDs, the defibrillators, and they're called defibrillators for a reason. They only work when you have fibrillation of your ventricle, so there's still an electrical pulse. And what these do is just sort of reset the pulse. If the heart is not beating, there's no ventricle fibrillation, more often than not, it's not going to do any good to do the. And an AED can sense that, and it's very uh, simple to use. You turn it on and it tells you everything that you need to do, and then you can go ahead and we have, I think, 4 now at Branham. There's one in the gym. There's one in this old student service center, I think, where now I'm trying to remember where they all are. But yeah, so there's 4 on campus. All right, so that's it for the notes, and we'll see you on Monday.